All right, this is lesson 1.2b in elementary algebra. Continuing on here, and I'm on page 20 with some definitions there. And the top one is the definition of equivalency. And it says fractions that represent the same number are said to be equivalent. They may look different, but they have the same value. So, for example, if I have 2/3 and I have 4/6. Those are equivalent to each other because this will reduce to that. Or this will expand to that, because if I take each one of these, if I take the 2 and multiply it by 2, and the bottom and multiply it by 2, I get 4/6. So see, what happens is if I multiply the top and bottom by the same number, in this case 2, I will get another version of 2/3. It'll be a fraction that's equivalent, that's equal, but notice they're different numbers. So equivalent fractions are fractions that have the same value, they just look different. And that's one of the things. You jump to property 1. You can multiply any numerator and any denominator. If you multiply them by the same number, in this case 2, you will get an equivalent fraction. It's legal to do that. It's the same with dividing. If I had, for example, 8/16, and I decided to divide this by 2, and I divided this one by 2, whoops, dot, dot. This and this are the same number. Now, if I divided this one by 2, and this one by 2, I'd get 2/4, which again, this, and this are the same number. They just look different. They're just different fractions. Now, when we divide fractions and we get them reduced even smaller than this to where they can't be reduced anymore, they are said to be in their lowest terms. They can't be divided anymore. That is divided out as they can go. Okay, so this next section that I'm going to use this number line for, called absolute values. Absolute values are so simple that they can be a little tricky. And there's a symbol that represents what we mean by the absolute value, and that symbol are 2 vertical lines with the number between it. And the way you read that as the absolute value of 5. The absolute value, all that does is it represents how far that number is within the absolute value signs from 0. Okay? So it is how many places from 0. Well, what if I'm here? I am 5 places from 0. What if I'm here? I am 5 places from 0. Okay? So there's really 2 answers there. -5 and +5 are both the same distance from 0. So when I'm asking you what the absolute value of 5 is, I'm saying, how far are we from this 5? Well, the answer is 5. If I have the absolute value of -5, how far is this 5 from 0? It's also 5. So the absolute value of 5, the absolute value of -5, both give you the same answer. And notice the answer that it gives you is its positive self. I guess I just kind of made that up. Its positive self. So -3, absolute value of that would be, how far is it to -3? Well, it's 3. Absolute value of 3 is also 3 away from 0. The negative sign, all that tells you is what direction, okay? It doesn't tell you how far. So, for instance, if you are driving from your house to McDonald's and it's 4 miles there, when you come home, it's still 4 miles, right? But it's not -4 miles. You don't say it's -4 miles. You just say it's 4 miles in the opposite direction. And that's kind of segues us into the idea of what an opposite is. Opposite is just the other direction on the number line. So the opposite of 4 is going to be -4. So we just went a different direction from 0. So the opposite of negative 5 would be positive 5. And that's all they are. Numbers the same distance from 0 but are in opposite directions from 0 are called the opposites. Okay? So, if I give you 1/4 and I say, what is the opposite of 1/4? You're going to say negative 1/4. If I say negative 3, you're going to say 3. Okay? So not too bad there as far as knowing what that is. Now, when you're talking absolute values again, and I'm bouncing around a little bit. The book does too. But when you're doing absolute values, is you do what's inside the absolute value first before you solve it. So if I do this, and this is example 7, you're going to do what's in the absolute value sign first, and then give me the absolute value. If I have 3 times 2 cubed times 2 times 3 squared, again, example 7. My 3 squared just doesn't quite look right, does it? Come on. Okay, do what's in the absolute value sign first. So I do PEMDAS of what's in the absolute value. 3 times, PEMDAS says we do our parentheses first. I don't have any. And then it says do our exponents. And 3 squared is 9. Okay, and then it says do multiplication. And so we start from the left, and we have 24 times 2 times 9. So I'm just doing a couple numbers at a time. 24 times 2 is 48 times 9. And then that gives me 432. And I copied the problem down wrong, but that's okay. Let's look at C in example number 7. It is 9 minus 2, absolute value, minus absolute value 8 minus 6. So we do what's in the absolute value sign first. So 7 minus absolute value of 2. What is the absolute value of 7? 7. Absolute value of 2? 2 equals 5. All right? So you don't take the absolute value off until you've solved everything and you have just one number in that absolute value sign. And then you can take the absolute value of that one number and then add, subtract, multiply, or divide, whatever it's asking you to do. Okay? So, that's pretty much it. If you jump over to the lesson in 1.2, I'm going to look there and see if there's any problems that might give you a little bit of a struggle, and we'll attempt those. Looks like the only one that I think, well, let's do number, 56. That one looks like that might be a little rough. So we have 25 minus the absolute value of 9 minus 3 times 4 times 5. Holy smokers. And that's all in an absolute value sign, minus 20. Okay, so remember, we do what's in the absolute value sign first. We will leave everything else alone. So let's do this in blue. 25 minus... All right, so we do the parentheses first, and inside the parentheses you have to do multiplication. Okay, so I just do one step at a time. It just makes it a lot easier. I don't make as many mistakes. 20 times 18 is 2. Okay, so again, all I'm doing is stuff in that absolute value sign first. So notice I'm still doing the multiplication first before I do any subtraction because of PEMDAS. Now my absolute value is down to one number, so I can take the absolute value sign off. What is the absolute value of 3? 3. So don't say 25 minus and get, the absolute value of 3 is 3, and make it a negative because of this here. So the minus stays, but the absolute value of 3 is 3, minus 2. And then you just subtract. 25 minus 3 is 22. Minus 2 equals, equals, come on, give me my equal sign, equals 20. My pen just isn't working right for some reason. Okay, equals 20. And that's it for number 56. So that's kind of the hardest one in there. There's some, looks like some story problems. So those should not really give you much trouble. If you jump over to 63, and I just noticed the little scuba diver guy. Not that I'm a scuba diver, but Steve is scuba diving near his home in Maui. At one point, he is 100 feet below the surface. So there's where Steve is. 100 feet down. Okay? Represent this number with a negative number. Well, if he is below the surface, below is always a negative number. Above is a positive number. Left is a negative number. Right is a positive number. So that would be represented as negative 100. If he goes down another 5 feet, he's not only at 100 feet, but he's at 105, and he's at negative 105. So, you know, not too bad. Shouldn't give you too much trouble there for 1.2. And 65 through 68, they're just looking at different calories. If you look at 65, let's say you weigh 120 pounds, so you look at the column there with 120 pounds going down. How many calories will you burn if you play handball for 2 hours? So if you burn 544 in 1 hour, in 2 hours, you're going to burn 1,088. Oh, and then you go and ride your bike for an hour. So 1,088 plus bicycling of 299. You add those two up, and that's what they're looking for. So not too bad there. So hopefully you'll let me know if you have any questions over this lesson. Happy to help you. And that's it for 1.2, B as in boy.